Hello everybody, welcome to another lesson by me, Miss Pythagoras. In this lesson, I will explain a typical exam question based on the cosine rule. This is lesson 5 of 5. The framework for a construction consists of a cyclic quadrilateral P, Q, R, S in the horizontal plane and a vertical post TP as shown in the figure. From Q, the angle of elevation of T is y degrees. PQ equals PS equals K. Units, TP equals 3 units and angle SRQ equals 2x degrees. Number 1. Show, giving reasons, that angle PSQ is equal to x and angle PSQ is also S1. So we can start by saying that angle P1 plus angle R is equal to 180 degrees and your reason, opposite angles of a cyclic quad supplementary. But we know it was given that angle R is equal to 2x. Therefore, P1 is equal to 180 degrees minus 2x. Furthermore, we can say that in triangle PSQ, angle P1 plus S1 plus Q1 is equal to 180 degrees and the reason, angles of a triangle supplementary. Then in P1's place we can substitute 180 degrees minus 2x plus S1 plus Q1 is 180 degrees. Then the 180 degrees and the 2x will walk across and we can say 180 minus 180 will cancel and I'm left with 2x. Then S1 plus Q1 is equal to 2x. But it was given that PS is equal to PQ. Therefore, angle S1 is equal to Q1. And then we can say 2S1 is equal to 2x and we can divide away the 2. Therefore, S1 is equal to x. Before we continue, have you subscribed yet? And a reminder, you can also visit my website onlinemaths.co.za. The link is in the comments below. There you will find all the chapters in the syllabus. Also, feel free to leave a comment or like my video. Let's continue with the maths. Number 2. Prove that SQ is equal to 2k cos x. And there's SQ. So we can start by saying from the previous slide that angle at P, SPQ, was equal to 180 degrees minus 2x. The angle at S was x and the angle at Q was also x. So now to work out the length of SQ, we will use the cosine rule since we have two sides and the included angle. Then we can write the cosine rule as SQ squared equals PS squared plus PQ squared minus 2 times PS times PQ, the cos of P. PS is equal to K squared plus PQ is K squared minus 2K times K, the cos, and angle P is equal to 180 minus 2x. Then we can say K squared plus K squared is 2K squared, and then 2 times K is negative 2K squared, the cos of 180 minus 2x. Now the cos of 180 minus 2x, that's a reduction formula, and we can reduce that to cos 2x. But you must be careful, since in the 180 quadrant cos is negative, you will end with a negative there, and then a minus times a minus is a plus. So that one becomes 2k squared plus 2k squared, the cos of 2x. In the next step, I will pull out 2k squared as a common factor, and I'm left with 2k squared bracket 1 plus cos 2x. Now, cos 2x is a double angle, and you have three options for that one. So the one I'm going to use here is 2 cos squared x minus 1. And then I can say plus 1 minus 1 will cancel, and I'm left with 2k squared times 2 cos squared x. And then I will say 2 times 2 is 4k squared cos squared x. Then on the left hand side there's sq squared. I want sq. Therefore I will take the square root on the right hand side. And then the square root over that will give me sq equals 2k cos x. Question 3. Hence, prove that SQ is equal to 6 cos x over tan y. So now, in the right angle triangle TPQ, to include the 3 and the y, we can say that tan y is equal to TP over PQ, because tan's ratio is opposite over adjacent. Then in TP's place I can substitute 3, it was given, and in PQ's place K, that was also given. And now I can make K the subject of the formula. Therefore K is equal to 3 over tan y. Then from the previous question we know that SQ is equal to 2k cos x. And now we calculated K here, and we said K was 3 over tan y, and then we can multiply. Therefore, SQ is equal to 6 cos x over tan y. Thank you for watching. There is also a link to the playlist Compound and Double Angles in Trigonometry, and then there's also the link to another trigonometry lesson, How to Prove Identities. This is Miss Pythagoras signing off. Till next time.